Hello, everybody. We are going to be looking at our Unit 14 topic for tonight. And I'm looking directly at the PDF that we have assigned as a reading. And this comes from our IT and business textbook, which is basically an MIS textbook. And it has this really good section at the end of it called the Technology Guide, where they do focus on cloud computing as a special extra section of the book. The interesting thing about the textbook that this comes from is that they do this like weird thing where they kind of break it down into like, why are you in this course? Like, are you a management person or a business person or whatever? And they all have these little indicators as you go through the readings that might, make more sense for your discipline or profession or whatever it is. So they try to cover a big wide gambit. As they start to discuss even what cloud computing is, and this is a thing you see it in commercials all the time, and why are people doing all these commercials? Because cloud computing is big business, folks. I think I've mentioned to you that the biggest driver of income for Amazon is its Amazon Web Services, which is its cloud platform for selling computing services to others, and that drives most of their revenue. Which is astounding when you think of how big their retail revenue is, which is, monstrous in and of its own right. A lot of people are doing cloud computing. So the big three in cloud computing, and probably in this order in terms of prominence, would certainly be Amazon, followed by Google and Microsoft, catching up ground really quickly lately, by the way. There's other big vendors in the cloud market too. They're not the only three. IBM is pretty huge in the field as well, and there's a host of others that are starting to, enter into it for a number of different reasons. One little interesting piece of news I got from our dean yesterday, as our Data Analytics 1 class was starting up. He went for a visit to Foxconn and told me that they have their data centers, nearing completion, and they're hoping to get this big contract to build servers. Predominantly for Google and their server farms right there at that location. And if they win the contract, a lot of that assembly work will happen right in our back door, which is pretty cool. Their data center is no slouch either. They've created this building that looks like a big golf ball, for lack of a better description. That is their data center. And I'm hoping to go tour it. Our dean's trying to arrange that. And if I can arrange tours for myself, I'll see if I can arrange tours for my students, because I think it'd be really kind of cool to see one like that. All right, but when cloud computing didn't just come from nowhere, and that's what this first section of the reading is about. It talks about the era when we used to use computers in a very different ways. And what's happened is we've kind of moved through the decades, and as each decade progressed, we kind of had all different ways to do things. And we began with big standalone mainframe systems. So when you look at this document here, that's kind of like the first era. And we went from like the big ENIAC machines, and then we went to commercial mainframes in the 50s and 60s. So a lot of big companies and organizations could afford them, but they were really expensive. And they didn't even have terminals hooked up to them. Like one person, in the basement ran the machine, and you gave them your data or whatever, and they ran the programs and got the work done. And that was the era of standalone mainframes. From there, they came up with an idea kind of like in the early 60s, and it took a while to really kind of push the whole concept through the industry of the mainframe powering the dumb terminal. And so you'd have these big machines in the closets, and then you'd have these, like we talked about before, keyboard, mouse, and monitor on your desk that really don't do anything but are connected to that machine. And that era, it was really kind of like, I'd say mid to late 60s, well through into the 80s, folks, that era was happening. And there's a lot of big organizations that still run dumb terminal environments for certain applications. And people are always like, why do you run something so old? And here's the answer: it works, right? It does just fine. There's no reason to change it, especially for things such as, inventory systems. You see it quite often, or in manufacturing systems often. We then kind of moved into this era, kind of late 70s and 80s, where we started getting, personal computers on desks inside of work environments. And that's all well and good because now you could do stuff at your desk without needing a mainframe, but very inefficient. So they added networking into the mix. So now the computers could kind of talk to each other, share files, and print to the same printer. And in some cases, also connect to those big mainframe systems or servers. And so that was kind of a big step forward. And when local area networks really kind of became heavily entrenched in organization, really it kind of started around the mid 80s, but it really didn't take off until the early 90s, if not even the mid 90s, when people really started to get their machines connected. That's right around the era when I started working in IT, and I started first in support and hardware roles. And at my first job, we didn't have a network. Everybody had PCs. And then we're like, well, wouldn't it be great if we didn't have to like put our, document on a disk, walk over to the computer that's by the printer, load up the document and print it. That's how we used to have to do it when I started. And then I'm like, they do have this thing called a network. I could set one up, and so I actually volunteered myself to set up a network at where I worked. And I manually wired everything. I didn't know any better, right? I didn't know you could buy pre-configured cables and they were expensive, but I learned how to wire everything from the ground up and built a network, and started networking all the stuff on campus back then. As those networks kind of came into heavy use and people started realizing, well, hey, if all the computers are on the network, we can take this one big machine that runs our applications or stores our database or our files, and we can put that in the closet. It's kind of like the mainframe, but maybe not quite as powerful or expensive, but a lot more flexible. And this combination of personal computers and servers form this client-server computing era. And as that kind of came into play, then all of a sudden it really kind of enabled the next era, which was enterprise computing. And by the mid to late 90s, it was firmly entrenched. So we started seeing a lot of network-based applications coming into the mix. And I'm thinking of things like Lotus Notes and Group Wise and some of these antiquated products you don't even hear about anymore. But also products like SAP and big ERP systems that are still around to this day, where they're kind of like this one conglomeration of a lot of different applications that do a lot of different things and really tie an organization together. And so in enterprise computing, you might have your accounting department using the software, your inventory department using it, your salespeople using it, and it's all linked together. And that really started happening in the late 90s. It also kind of coincides real strongly with the big .com boom that was happening back then, because a lot of the people that were selling the services started to become internet based, and we started moving into the cloud computing era actually by the late 90s. It really didn't become super huge until I would say the mid 2000s, and we started seeing huge server farms going up as the internet grew and everybody started getting devices, multiple devices. We started pushing more and more stuff to web services, more and more stuff into the software as a service platform. And now we're in the era that we are now, where in some cases we're using this stuff, we don't even realize we're using it, and that's okay. So that's a really big piece of understanding things. And I thought this was kind of interesting, these yellow headings here, where they start talking about some of the characteristics of cloud computing, if you're trying to like put it straight in your head. The one thing that they mention here first is that cloud computing provides on-demand self-service. So if I'm at home and I want to grade you guys, I can log into Blackboard. It's a perfect example of a cloud service that Gateway pays for. And very interestingly, in the early days of using Blackboard at Gateway used to install Blackboard on our own servers, and it ran on premise. And I was astounded by that. Alan Pearson was telling me that, one of our software instructors, and he goes, yeah, Ty, we ran it on premise, and you know what? It was a whole lot snappier. It worked a lot faster because the signal doesn't have to travel so far. But it caused a lot of problems as well. So like if that server went down or something happened to the connection, there's everybody's courses and everybody's grades, gone, right? Problem. So what they decided to do roughly 12 years ago is they decided to switch to the cloud version. So they switched from hosting it on premise to just paying for it as a service. And they just migrated all our data and accounts and everything over to the cloud platform. And we were up and running. And I guess the transition was really, really fast because Blackboard has a lot of experience doing that. But the fact that, I could access it remotely, and I guess in the past that was not entirely possible off campus, at least not initially. Next bullet says, cloud computing encompasses the characteristics of grid computing, which, and if you read the description there, it says it pools various hardware and software components to create a single IT environment with shared resources. And that's very typical for a lot of organizations. So just as an example, you might have servers set up for your organization, whether on-premise or in the cloud, that do a variety of things. One real big task for a network would be to authenticate the users that are attaching to it, right? So you sit down at your computer, you log into whatever OS or thing that you're doing, it recognizes that you're the real person, and then it gives you access to all these other systems. And that happens at Gateway in our office environments. And that service, like on a Windows environment, is typically called Active Directory, for example. But then once you get past that point, you clear the authentication level, then all of a sudden I have access to file shares, that are on the network. I have access to certain applications that I wouldn't be able to access otherwise. And it's all privatized, it's behind firewalls, it's all protected. But it's really a combination of things, and we kind of think of it as one big pool of things, but the reality is there's a bunch of applications and services running together to kind of create the whole ecosystem of what Gateway does. Some of it on-prem, some of it in the cloud, some of it software as a service, interestingly. Gateway does run a lot of its stuff on-premise, though, which is pretty interesting. Blackboard is one exception. The Google App Suite is an exception as well. Office 365 also, I guess, fits in that category. Cloud computing encompasses the characteristics of utility computing, meaning that the stuff that we have available to us is really kind of designed to be most effective for whatever task we're doing. And that's kind of the point there. It also utilizes broad network access. In fact, cloud computing without good network connectivity is basically useless. So you don't want to be connecting to cloud services that have really slow connections. Just a little thing that I described with Blackboard, where when we used to run it on premise, it was a little bit faster, sure, because the server's down the hall in the closet. Now you're connecting to something that's over in Pennsylvania. That's where Blackboard operates from, and they run their own server farm. At least last I checked, they did. A lot of people then migrate to different platforms. But a lot of these data centers where these servers sit have huge internet connections on a scale that we can't even fathom for home usage. Very typically, even a small server farm. And I'll give you an example. I visited one in Kenosha that's right along the lakefront. And this small little server farm cold site place, which houses a lot of Milwaukee's major corporations, by the way, like Northwest Mutual, Harley Davidson, and a couple of others, Briggs and Stratton, had 4 redundant internet connections, each of 100 gigabit capability up and down. 5 redundant connections from 5 different service providers. Now, I want you to think about that. And this is a small server farm. And what they're doing is they're using all 5 of those connections simultaneously. If one fails, no problem, traffic kicks over to one of the others. And that's why they get it from 5 different sources as well, because you can't have it that you got one internet provider, the line is cut and you're down. All those companies would fold, right? Northwest Mutual not being able to access their records is a big problem. And so many of these data centers have huge redundant pipes, hugely expensive, but super, super high capacity as well. Cloud computing also pools together computing resources. So one thing that you can do when you have a large collection of servers is you can actually do what we call parallel processing, where you can have multiple instances of servers teaming together to act as one machine. And it's kind of a strategy that's been around for a while. It really kind of blossomed in the 1990s when people used to kind of experiment with Linux machines. But now it's very common in data environments where you just very simply can allocate more machines to a task. And so, for example, if the NFL is running a website most of the year, it gets a certain amount of traffic. But when they do the drafts, right, traffic picks up, and then when the season starts, traffic picks up, and then when the Super Bowl hits, traffic is crazy, and they can't afford to pay for the level of service they would need during the Super Bowl, but they can automatically scale it up, and they parallel process it. They just flip on a bunch of other servers, they share the workload, and it's parallel processing. So they can, at a moment's notice or on demand, just turn on more machines and handle the workload. And that's what pooling resources does. Then we have this aspect of virtualization, and this is the thing I'm going to demonstrate next, by the way. What is virtualization and how does it work? Well, this image that they have here is kind of interesting because this is probably not too atypical looking of a server farm or setup somewhere. And then you look at these machines that are tucked in here, and maybe like one of these rack spaces, and this might not be the best graphic really, but often a high-powered server for an organization fits into what we call a 2 rack unit space. In other words, it's about I'm going to say 4 or 5 inches tall, 19 inches across, and usually a couple of feet deep. And that holds all the computer hardware that runs a server. Now, a server will be a lot more powerful than a regular computer. It'll have significantly more CPU cores, significantly more memory, things such as redundant power supplies, so not one power supply, but 2. So if the one burns out, power stays on. Redundant network connections, et cetera, et cetera, et cetera. And then those machines are sometimes so high powered that there's no reason to necessarily allocate the whole capability of the machine to run one task. It makes no sense. And so what people do is they'll take that machine and they'll run a host operating system on it, and then split up the server's capabilities to allocate the RAM, the CPU, and the disk space to various virtualized servers. So servers that operate seemingly as their own machine, but really are just a piece of software running on top of one server. So one physical server might host a couple dozen, or sometimes even hundreds of virtual servers on that one machine. And then when you start to take that and go, well, that's one rack space, and here I have a whole building full of them, floor to ceiling, and now your head starts to turn and go, wow, so this rack here might have 1,000 servers in it. Yes, and that's how it works. Very bizarre. Once you see the little demo I hope that it makes a little bit more sense. They have some interesting graphics here about like how the internet works, and very often when we think of the internet, we start to diagram it. You'll have like people sitting at a computer and connecting to something, and then it goes into the cloud, right? And typically we think of that as the internet. But cloud, in terms of the definition here, really is kind of an indicator that it's happening somewhere else, usually in a server farm, on a remote server. And yes, typically the traffic travels over the internet to get there. However, there's also circumstances where some of those connections are privatized. So for example, Gateway has private network connections that run from campus to campus. So we have paid for dedicated private lines that only Gateway can access. So like if somebody's on a registration system in Elkhorn, it's directly connected to our systems in Kenosha. And there's nobody can even tap into that system because it doesn't travel over the same wires that the regular internet connections do. So Gateway has leased lines for private network, wide area networks, and then has public lines for the public network. By the way, all our internet traffic at Gateway, regardless of what campus you're sitting at, it all funnels back to Kenosha and then goes out to the internet. So that's kind of interesting. So it does. So if we're on the Racine campus, your internet connection has to go to Kenosha first and then go out. One little interesting side note, though, is that our IT department, at least in Racine and Elkhorn, have been given permission to isolate our networks and create our own separate internet connections. And I think they're going live this summer. So that should be kind of an interesting change, and kind of a long story in and of itself. All right. We talked about the different kinds of clouds when we were doing the Kahoot. The public cloud, we gave the example of like the Google App Suite, for example, is a good example there. Don't need it to pay any money. Just go in, set up an account, boom, you have an account, and it operates out on the cloud. A lot of applications operate that way. There's also private cloud. So in other words, Gateway might once again be a really good example of this, because here we have all of our, let's say, registration systems sit on servers at the Kenosha campus, and actually in the bioscience building, if you're curious. And when I might be in Racine or Elkhorn and we're connecting to it, well, we kind of have our own cloud infrastructure in a sense, because it's over private lines. The servers are in one location, but they're not physically in the same location where we are. So we're connecting to something privately that's, kind of a cloud. So Gateway has kind of its own private cloud. But if you take it a step further, you can also establish a virtual private cloud, if you want to think of it that way, on public infrastructure. So Google can sell you, for example, server space that you can create dedicated, or encrypted connections to that are privatized within their system. So whatever data is on those machines cannot be polluted from other machines. So other people aren't on your machine, basically. The server, stuff that you're getting is pooled together in its own little private cloud virtually. Then there's this hybrid cloud, and I know you see those like IBM commercials all the time that talk about hybrid cloud, where really what they're saying here is and this is what most organizations are doing currently, by the way, is they have a combination of both on-premise and cloud-based services, because it just makes the most sense. And if you have something on-premise that works just fine, why move it to the cloud? If it's not costing you any money, you move stuff to the cloud, you might be saving the costs on the people running it, but now you got to pay these monthly fees to some other organization. But the reality is a lot of people have combined those things. And I did see the question came up in the chat. Okay, so the question was, and it's not a dumb question ever, right? If you don't know, but how is a private cloud different from a WAN for an organization? So the WAN really refers to the structure of the network connection. And so Gateway has that in place too. So we have a wide area network, meaning our campus locations are connected together through, and more than just a couple of miles, 10, 20, 30, 50 miles. I forget how far it is to Elkhorn, but it's a pretty good distance. So it's over a wide area, but it is a private network. So the WAN would be the infrastructure or the wiring piece of that. The private cloud is kind of the server and application structure that runs our apps that might be on the internet or could be in our WAN, could be either one, that allows us to do our work, right? So it's more the software layer of it most typically. So I hope that helps to clarify it, but that was a good question, absolutely. A WAN would be infrastructure. The private cloud is kind of a virtual construct that can be internal or external on public infrastructure. They do have this other type of thing now that we're talking about vertical clouds, and there's actually a website for us if you guys want to kind of like, oh wow, okay, I guess not anymore. If you guys want to buy a domain name, there you go. And of course, I closed my thing here. All right, so it just shows you that links sometimes die. It's the nature of the internet. And almost done here, folks, with the presenti part. And then we get to the thing that we had the issue on the exam with, and we kind of talked about this during the Kahoot, but this little document or image here kind of, I think, really well explains the whole thing. And once again, just to be really clear, I had a couple people that emailed me about that one question, And the correct answer actually was software as a service after reviewing this and doing a little other research. And originally the test was set up to indicate that this was the correct answer. And I have restructured it now so that it graded correctly. But it really is more of a matter of, the far end of the spectrum is all on premise or all out in the cloud. And then it's really a matter of who manages the infrastructure. And then I really like the little app list that they have down here that shows you, like, what companies are working that way or what apps operate in these spaces. All right. Talk about the personal cloud, and I think the Google Drive thing is probably some people would think of it as a personal cloud, but that's really pretty private. An example of a personal cloud, I guess I'll go back up to that because now the funny thing is a lot of people are starting to get really clever about how they manage their IT stuff, even personally. So, like, for example, when I discovered, for me, the killer app that pushed me into the cloud first was an application called Dropbox, and I loaded up on all my machines, and it works like OneDrive or Google Drive, where you can put files into it, and then it replicates to any device that's connected and has the software loaded. Now, you don't have to load the software; you can do it all web-based. But when you do run Dropbox, and I'm just kind of like giving you an example here, I have a bunch of files in there, and anytime I drop files into my Dropbox, what happens is this. If I drop a file here on this machine, and then my machine next to me, which is also connected, the physical folder on here will push it up to my Dropbox account, and that Dropbox account pushes it over to my other laptop. So I kind of, in a way, am forming a personal cloud. And some people take it even further, because that's really a service, frankly. Some people will set up servers at home. Do you know anybody like that? I know quite a few people like that. And some people first will start with, like, well, I put all my movies and my games and my music on a server at home. Then they start getting smart, like, well, hey, if I can share it at home, I can probably share a port out to the internet, and then I can be anywhere and I can get to my stuff. And so people are starting to get savvy that way and set up their own personal clouds, or in some cases, pay for outside services to do exactly the same thing. And I think you're going to see that as a growing trend. People are probably going to migrate more and more towards simplified personal computing devices. And the ones that won't will be people who do either gaming, audio, visual, or any sort of engineering or coding production work. Those are the people that'll work on full-blown systems, and everybody else probably in a while will all be on Chromebooks, because, hey, I can buy a Chromebook for $200, and then I can log into whatever I want and do the same thing I can do on my regular computer. So why do I need an expensive computer? And then the answer is because I want to play Battlefield, right? Or I want to edit a movie, or I want to write some code. And that's when you would buy a real computer. But I think that you're going to see that kind of exploding in the next few years. Interestingly, they have a couple of listings here, the benefits of cloud computing. And some of this, I will say, frankly, I think is arguable, because I think there's benefits and pros and cons for everything, really. But they say here that it has a positive impact on employees, because if you don't have to sit there and install stuff on people's computers and do upgrades, they can just get to whatever they need through a browser. Hey, fantastic, right? A lot easier to manage from a support perspective. It can save a lot of money. Hey, I used to have a whole IT department, pay all these people, I got to buy the equipment, I got to upgrade the equipment, I got to back up the equipment, I got to power it, I got to air condition it, all that stuff. Push it into the cloud, I pay a monthly fee, and you can save a lot of money. And I have, like, the perfect example of that is when I first started doing my web business. I started creating web pages for people, and then I knew how to run servers. So I'm like, hey, you know what? I'm going to have my own web server, and I'm going to sell space on it. I'm going to be huge. That was kind of my mindset. And I would pay literally hundreds of dollars a month to have a T1 line, laughable at this point, and to have all the infrastructure. And then I started calculating. I'm like, oh my God, I'm spending like thousands of dollars a year just to keep this one machine going. Oh, I can get business hosting for $12 a month. and I can do all the same stuff, I'm sold. It was very easy to transition over to that, and I just moved all my clients into the cloud that I had. They didn't know the difference. It worked better. I didn't have to do any backups. I didn't have to run to the office if the server was down in the middle of the night and get it back up. None of that. And it saved me a fortune. If I would have known that off the bat, yeah, save a ton of money. It says cloud computing can improve organizational flexibility and competitiveness. Perhaps, I'm going to say this is an arguable point. I mean, if you are saving money by allocating your resources to elsewhere, of course, like the 3 IT people we just fired because we pushed stuff into the cloud, what happens to them, right? But maybe those people can be reassigned to something better, or maybe you hire other people to do other tasks. And in some cases, you still need to keep those IT people, because even though stuff is in the cloud, you still have to have user accounts, and you still probably have to do file backups and all those sorts of things. A lot of it is automated, granted, but yes, it can really benefit an organization. Some of the things that cause problems when you're moving to the cloud. Well, what if you have old systems that can't be migrated? All right, well, that's a big problem, and a lot of organizations do. You would be surprised how some big modern organizations use some really ancient systems. Next time you walk into Costco, take a look at their inventory system and notice it's all like green screen, like coded back in the 80s kind of stuff. And why don't they switch away from it? I asked one of their managers once, he goes, yeah, I went to a conference on it. They're not going to change it because it works great. And it's really fast. I'm like, okay, right. So they're not going to change. They have a way to like network it and everything. So they keep it running. Another concern is reliability. So what happens if you lose your internet connection? All right. So in the past, if you lost your internet connection, but your stuff's on premise, chances are you can still keep working because your servers are right there. But now you have to worry about, and Gateway is not alone in this, that they also have to have multiple connections to the internet. We can't just use AT&T, and we can't just use Spectrum, and we can't just use TDS Metrocom or Midwest Cable or whatever the companies are around here. In fact, Gateway uses all of them simultaneously, because if one connection drops, we can't not be connected to Blackboard, for example. We must be, right? And that's out in the cloud. So if we don't have redundant internet, it's a problem. But what happens if the server farms go down? So usually server farms are so overbuilt that never happens. What most people freak out to really when they start putting stuff in the cloud is this thing, which is privacy. Can other people intercept my data in transit? And it's all about how it's connected. If you transmit the data encrypted, highly unlikely it will get cracked in transit. Very unlikely. But if people can hack something on site, they can certainly hack it in the cloud. So yeah, there's a big concern. There's also a concern in some cases, depending on who you're buying the services from, whether they can access your stuff. And I think that's kind of profound to think about. And then finally, security. And those two issues are kind of related, but this is kind of a challenging thing right now. Cybersecurity might be one of the most daunting concerns we have. There's significant hacking happening all the time. It actually increased during the pandemic. I think all the hackers are sitting at home bored, so let's hack some more. But that's a big concern for people. The other thing is some people are concerned with what types of regulations and legal aspects might happen. So like, does it change how the government regulates you, depending on where you run your stuff? And see, a concern for an organization like ours, where we're dealing with educational records, that's protected. And Dennis, I know you work for a healthcare company, and that's protected also. So you guys have to be keenly aware of the security, because you do not want to compromise data. And if you do, then you're subject to, federal litigation, from the U.S. government. They'll come after you because you're not protecting people's data. It's huge. Although ironically, the government's been hacked many times itself. So a lot of people also are concerned that there's a lot of criminal activity that happens out in the cloud, and that's true. But you know what? Criminal activity happens everywhere, right? And that it's unfortunate, but it does happen. And yes, a lot of people who are criminals and do criminal IT activities will host, their botnets and their, malware and all that kind of stuff in the cloud. You got to catch them, right? But they put it out there, and so some people worry about, if they're doing something nefarious on that machine, and your virtual server just happens to be on the same virtual server. What does that mean? Am I at risk? And some people don't understand how it works. But people use the power of the cloud also in other ways. And this is kind of an interesting thing, because if you're running your own servers, you have so much capability, right? If I can cloud compute, I might be able to afford more computing capability in the cloud than I can on premise. And so I might be able to do something like run a password cracker, or something like that, or a decrypting algorithm, or a decompiling algorithm to hack somebody's software. And if I have the power of cloud computing behind me, where I can scale up these huge server environments to run these automated tasks, I might be able to hack a lot more efficiently. And that has been happening. So people that have money and are hackers, they buy server space and they use that to launch attacks and to crack passwords and Wi-Fi and encryption. So very kind of scary era in a lot of different ways. We also talked about the web services thing, and really, I think we covered that pretty well. And a lot of it really is enabled by all the web languages and technologies that we have, the fact that they're pretty universal and operate under just about any operating system, platform, browser, you name it. It's really what's kind of enabled it. We learned a little bit about HTML and XML prior. And then that's the chapter, folks. So I'm going to stop the recording here,